on this part of chemistry that is mainly about chemical calculations, we'll talk about 5 points. The first point will be about molar mass and things related like mass, number of moles, Avogadro's number. Second point, we're going to talk about two laws, which is law of constant proportions and law of multiple proportions. Then third point, we're going to talk about ratio of mass. And also we're going to talk about another point, which is the difference between molecular and empirical formulas. And last point, we're going to talk about hydrated salts. Okay, for the first point, which is mass, molar mass, Avogadro's number, number of particles, we know all what does an atom mean, and we know all the elements in the universe, they contain atoms, and the atoms of each element are different from the atoms of another element. Okay, these atoms are very small, and we cannot see them, and we cannot deal with them as one atom, two atoms, three atoms. So in chemistry, in chemical calculations in general, and in calculations in general, we deal with things that are easier to us to use them or to understand them. For example, when we say a city, the distance between one city to another city, we cannot use millimeter or centimeter unit because it's very small. So in this case, we use kilometers. So that means we use a unit that is related or relative to our human understanding. So in chemical calculations, in understanding the mass of element, mass of a compound, molar mass, we don't deal with them as one atom of the element. We deal with them as a group of elements. Group of atoms. Group of atoms, for example, now imagine you have 6, 0, 2, and here you have 21 zeros. Imagine now you have here 21 zeros with this number. Now imagine 1, 2, 3, 4 till 21 zeros. You imagine this number now. It's a very huge number. This number is called Avogadro's number, and it is written as scientific notation 6.02 times 10 to the power of 23. And this number now is group of atoms. This number now, it represents number of atoms. So if you have number of atoms of any element, you have this number of atoms. In this case, you call this number of atoms 1 mole of atoms. And we deal with, in chemical calculations, we deal with the atoms as 1 mole. That means we deal with them like group of atoms that are this huge number of atoms. In this case, we call them 1 mole. So 1 mole equals, this one now is called what number now? It's called Avogadro's number. Avogadro's what? Number. So what is Avogadro's number? The number of atoms that are 6.02 times 10 to the power of 23. Okay, this is now number of atoms if we are talking about one element. And also this number, it represents number of molecules if we are talking about a compound or element that we deal with it like molecules. And you can understand that when we make questions. So here now, in this part now, we need to remember one important formula that equals number of moles. Number of moles now equals, if I have now a lot of particles, whether they are atoms, molecules, okay, or compounds. If I have a lot of particles now, these particles now, I need to understand how many moles they represent. So that means what I should do, just I use this formula, which is now number of moles equals number of particles over what? Over Avogadro's number. Over Avogadro's what? Number. Okay, we're going to take an example here in this case. If I have number of particles here, if I have like 12.04 times 10 to the power of 23. This is now number of particles. And I'm asking now, what is the number of moles? What is now the number of moles. What are you going to do now? You're going to write that number of moles equals number of particles, and as you see, number of particles is given here, which is 12.04 times 10 to the power of 23. You divide it now by what? By Avogadro's number, and this Avogadro's number, you need to memorize it. You need to memorize what is Avogadro's number, which is this number. You see it? This is now Avogadro's number. It is 6.02 times 10 to the power of 23. So that means I divide them now by this number, 6.02 times 10 to the power of 23. As you see in math now, this 10 power 23 will go by this 10 power 23. What is left now is 12.04 over 6.02. When you divide them, as you see, you will get what? 2. So that means the answer will be what? 2 moles. How did I get that number of moles? As you see, by using this formula. What is this formula now? To get number of moles. Number of moles, we divide number of particles that are given, whatever is that number, I divide it by Avogadro's number. If a question comes to you in this way, they'll give you a number of particles that is in general a multiple of what? Of Avogadro's number, in order to get number of moles integers to make it easier. But even if it is given to you in other numbers, you know how just it's a process of dividing. So memorize now, in short, memorize this formula. Number of moles equals number of particles over Avogadro's number. This is now the first idea of this point. Okay, what is the second idea? It's also number of moles. So just look here now. So number of moles, we said number of moles, it equals number of particles. Number of particles over Avogadro's what? Avogadro's number. Good. Here now, as you see, this is a first formula, or formula number 1. Okay, formula number 2, and also it is important, it also number of moles. Number of what? Number of moles. It equals what? Mass over molar mass. Over molar mass. So that means these ones are 2 important formulas in understanding molar mass, number of particles, and Avogadro's number and mass. Okay, number of moles equal mass over molar mass. Okay, now we will not use this one now till we understand what does it mean, molar mass. So we're going to understand first what is molar mass, and then we'll move back to complete this formula. Here, for example, as you see, this is the periodic table that we all know. It contains the elements on Earth, and all these elements, as you see, are ordered based on their atomic number, which is number of electrons or number of protons. Okay, here, this number, as we know, this number now, for example, hydrogen, it is written 1 here and 1 here. And the number that is up, it represents the atomic mass. And here, this number is the atomic number. Okay, we're going to take here, for example, carbon. And this is carbon. How you write it? We write it like 12, and here is 6. Okay, what does that number represent? The number that is up and also the number that is down. This one, it represents the atomic mass. The atomic what? Mass. And here it represents what? Atomic number. Okay, in molar mass and Avogadro's number, usually we use the mass and we don't use the atomic number. So that means this number that is here is the most important. Okay, 12 here now, as you see, look here now, these numbers now, they're going to be rounded to the closest integer. So here now, as you see, for carbon, it's 12 point something, so we round it for 12. We round it for what? For 12. So carbon, we call it carbon 12. 12 is what? Mass. Okay, what is this mass here? Mass is atomic mass unit. By the way, this number represents 12 atomic mass unit, but it has another name and we need to understand it while we use calculations. Look, if I tell you now this carbon, as you see here, it's 12. When I tell you now carbon is 12, carbon is 12 here, how do I deal this mass of 12? And this is very important. Deal with this one now as molar mass. As molar what? Mass. Okay, what does it mean, molar mass? It means now the 12 here, deal with it like 12 grams. So whenever the mass of any element here, for example, as you see for oxygen, it is 15.99. So that means you deal with it like oxygen, what equals 16. And 16 now, how I deal with it? 16 grams. The mass of oxygen is 16 grams. But mass of what in oxygen? It is the mass of 1 mole of oxygen atoms. And keep that in mind. So molar mass, what does it mean? It is the mass of atoms in 1 mole of that element. So that means when the carbon here is 12 written, again, it means 12 grams, which is the mass of 1 mole of carbon. And I understand what's mean 1 mole of carbon atoms. It means 6.02 times 10 to the power of 23 number of atoms. These number of atoms that represent this number now, what is their mass? Their mass is 12 grams. Okay, now this is now for any other element. As you see, each element we have its atomic or its molar mass. Okay, do I need to memorize all the molar mass of these elements? No. Since the element that they're gonna ask about it, they'll give you its molar mass, but they're gonna write it like carbon equals 12. They will not tell you 12 is what. Just you need to understand that 12, it means molar mass. And what does that molar mass mean? It means the mass of 1 mole of carbon atoms in grams. I hope that is clear. So here, for example, now if we take another element here, for example, if we take sodium, as you see, this is sodium here, and it is 22.9. So sodium equals 23. What does the 23 mean again? What does it mean? It means molar mass. And what does molar mass means? It means now this 23 that is written for sodium, it means 23 grams. 23 grams as weight, as mass. Not weight, as mass. So that means 23 grams is the mass of 1 mole of sodium atoms. Good. So we understand now what is molar mass of elements in general. We understand. And it is written and it is given for us. The molar mass of each element will be given for us. That is, or that we need it in the questions. So molar mass, again, it is the number that is written here in the periodic table as the mass of the element. Good. What about if I have a molecule? Like what? Like, for example, in oxygen, we deal with oxygen usually like O2. And hydrogen, we deal with it like H2. So we don't deal with them as atoms, we deal with them as molecules. So in this case now, if I'm asking you now, what is the molar mass of oxygen? But when I write you oxygen, I write it to you like O2. And O2 now, it means O2, it means O and O, and there is here what? 2 bonds between them. So that means the covalent bond. So that means these 2 atoms of oxygen, they represent what? O2, which is 1 molecule of oxygen. So when I tell you now 1 mole, when I write you like this, 1 mole of O2, whether this one is written or not written, so that means we mention it like 1. So when I tell you now 1 mole of O2, that means I'm talking about 1 mole of oxygen molecule, not 1 mole of oxygen atoms. Okay, now what is its molar mass? This is the question now. So look here now, what is written for the oxygen and what will be given to you is oxygen equals 16. And this one now, it means 16 grams, which is molar mass of oxygen. That means the mass of 1 mole of oxygen. But this number that is given for you in the periodic table, it is the mass of 1 mole of the atoms, not of molecules. But here now, the molecule here, it has 2 atoms. So that means when I tell you here, 1 mole of oxygen molecule, here now, it means, how I read this one now, 1 mole of oxygen molecule. So that means it's no longer called 1 mole of oxygen atoms. That means it is 1 mole of oxygen molecules. And each molecule has 2 atoms. So that means now 1 mole of oxygen molecules, it represents 2 moles of oxygen what? Of oxygen atoms. So in this case, you need to multiply this number now by 2. So you say the molar mass of this one is 32 grams as what? As molar mass, but per molecule for oxygen molecule. Same thing for hydrogen. Same thing for hydrogen here. If you see hydrogen here on the periodic table, it is what? It is 1. And 1 here now, it represents the molar mass of what? Mole of hydrogen atoms. So when they tell you now H2, what is its molar mass? So that means in this case, they are talking about the molecule of H2. And we deal with H2, with O2, with F2 as molecules since this is how we find them in nature. We find them as a molecule since they make covalent bonds between them to be more stable. So they share electrons to be more stable. So we deal with them as 1 mole of oxygen. We deal with it like 1 mole of oxygen molecules. And same thing for hydrogen. So here now, what will be the molar mass of hydrogen in this case? It's going to be 1 mole of H2, whether the 1 here is written or it's not written. So that means it means 1 mole of H2. So that means you're going to multiply times 2 for the molar mass of atoms. So the idea here, when the molar mass is given to you for each element, it is given to you as a molar mass of atoms, not molecules. If you have a molecule and this molecule is written as 2 atoms, so that means you need to multiply this molar mass by 2. Okay, more idea here. If I tell you now what is the molar mass of water, which is H2O, what is its molar mass? What does it mean molar mass? That means if I have now 1 mole of H2O, 1 mole of H2O, what will be its mass? Okay, look here now. If I tell you now, I put here 1 orange, and here 1 apple. Okay, I put them in a box. And I need to tell you now, if I have 2 boxes, what will be the mass of these 2 boxes? What will be the mass of what? Of these 2 boxes. What are you going to do now? You're going to find the mass of the apple, then the mass of the orange, right? And you multiply them by 2 to get what? The mass of the whole box. Good. Here now, water, it represents a box. So that means 1 mole now, 1 mole of H2O, it represents 1 mole of each of its components. That means here now, as you see, H2 here now, that means we have 2 atoms of hydrogen. They make 1 atom with 1 atom of oxygen. They make what? 1 molecule of water. So that means now if this one is 1 mole, so that means we need to have 1 mole of this one and 2 moles of hydrogen atoms. 2 mole of hydrogen atoms, it means 1 mole of hydrogen molecules. Good. So here now, if I tell you now, the molar mass of hydrogen, as you see here, is H equals 1. And the molar mass of oxygen, we know it is what here? 16. So what will be now the molar mass of H2O? So you're going to multiply this one now by 2 because you have here two atoms. So 2 times 1 is 2. So that means for the hydrogen, its molar mass is 2. Okay, what about oxygen? Its molar mass will be here, what? Will be 16. Add this mass now, and this mass now, you'll get what? 18. So this 18 now is the molar mass of what? Of the whole compound, which is what? H2O. Good. We have another example here. If I tell you now, what is the molar mass of NaCl. What is the molar mass of NaCl? Get the molar mass of NaCl. First, I have to see what is written on the left of NaCl. If there is nothing left here, nothing written there, let me see it represent 1. And the number on the left of the compound, it represents number of moles. So that means here it represents 1 mole of NaCl. Get 1 mole of NaCl. But you need to remember, 1 mole of NaCl, its mass will be the mass of 1 mole of each of its components. So that means here now, this one, we have 1 mole of sodium, and we have here 1 mole of what? Of chlorine. So that means you have 1 mole of sodium and 1 mole of chlorine. If they combine together chemically, in this case, they're going to make 1 mole of NaCl, which is sodium chloride, which is the salt that we know. Okay, what is the molar mass now of the whole compound of NaCl? Again, the molar mass, it is the mass of each one of them, or the molar mass of each one of them, then as addition. So here now, what is the molar mass of sodium? Sodium here, it's 222 point. So sodium here, as you see, it is 22.9. So that means it is what? 23. And again, now I take it from the periodic table, but on the questions, they'll give you, for example, what is the molar mass of NaCl, known that Na equals 23, and chlorine, they'll give you here, as it is what? 35.4. They can round it with their, to what? To 35 in this case, for example. So if it is rounded to 35 here, now, if I want to get the molar mass of NaCl, just I add the molar mass of sodium and the molar mass of chlorine together, they're going to make the molar mass of NaCl. I hope that is clear. So you understand now what is molar mass of elements as atoms separately, and as molecules, and as compounds. We're going to take just one more example. If I tell you now that CH3COOH, this one now is a compound, and it is, as you see, it is ethanoic acid. Good. This ethanoic acid, now if I ask you what is its molar mass as a compound, you're going to see first what is the number written on the left. It's 1, so that means 1 mole. And 1 mole of a compound, it equals the mass of 1 mole of a compound equals the mass of all its components. Good. What is now the mass of carbon? I have here carbon and I have here carbon. The carbon here, as you see, it is 12. So carbon equals 12. Good. And I have here 2 carbons. Pay attention here. So that means 2 12s. Good. What about oxygen here? I'm going to use red. Here I have 2 oxygen. And each oxygen, as you see, is what? Is 16. So I have 2 16s. Good. What's next? Next, I'm going to use white, which is for hydrogen. Hydrogen here, as you see, I have 3 hydrogens, and here is 1. So that means I have 4 hydrogens, and each hydrogen here, each hydrogen, it equals what? It equals 1. Okay, now if I go to add them now, if I go to add them, for carbon, how many we have? For carbon, as you see, for carbon, you have 2 carbons. So that means 2 times 12. Get this is for carbon, which is equals what? 24. Okay, for oxygen now, how many oxygen we said we have? We have 2 oxygens. So that means 16 times 2 will give me what? 32. Good. What about hydrogen now? Hydrogen, we have 1, and the hydrogen will be, as you have here, 4. So that means it's going to be 4 times 1 equals what? Equals 4. So now what I do now, to add them all, I need to add them all to get the molar mass, which is the mass of all this compound in grams. So that means 4 here I have, and here 24, and I have here what? 32. If I add 4 to 24, I'll get 28. 28, add the 2 here, it's gonna be what, 30, and another 30 is gonna be what, 60. So that means the molar mass of this compound is 60, and 60 means what? It means 60 grams. 60 grams. 60 grams as a mass of 1 mole of this molecule. So this is now molar mass. So you understand molar mass again for elements alone, for molecules, and also for what? For compounds. Okay, if I have now, if they tell me now, if a mass of oxygen, if they give me this question now, mass of oxygen, get mass of oxygen. Mass of oxygen is 38 grams. Good. And molar mass of oxygen, also of oxygen, is 16. Then find number of moles. Find number of what? Of moles. So here now we go back to the previous equation that we stopped. What was the previous equation we said we stopped at? It was number of moles equals what? Equals mass over what? Over molar mass. Over molar what? Molar mass. Here now, as you see, what is given for us here? What is given is the mass. So that means this is what? The mass, and it's given for us. And here it was given what? Molar mass, that is given 16. So in this case now I divide the mass, that is here I'm gonna make just the number 48 to make it easier here. 48 instead of 38. So that means I'll divide 48 over 16. I'll get that the result is 3 what? 3 moles. It's logic. How? If the molar mass, logic, and you can solve it mentally. If molar mass of oxygen is 16, and 16, as we said previously, it means 16 grams per 1 mole, for 1 mole of oxygen. Good. That means if I have 1 mole of oxygen, its mass is 16. Okay, what about if I have 2 moles? 2 moles, that means as the number of moles is doubled, the mass will be doubled. So that means it's going to be 32 grams, the mass of 2 moles of oxygen. Okay, what about if I have 3 moles? 3 moles, their mass will be what? 48. So logically, if you have a mass of oxygen that is 48 grams, it represents what? How many moles? It represents 3. But if I have a complicated numbers, what I do, I just divide the total mass that is given for me of a compound or of an element divided by its what? Its molar mass. In this case, I get number of moles. So you understand now how to find number of moles based on mass over molar mass, and you understand how to find number of moles based on number of particles over what? Over Avogadro's number. And he said these ones are 2 important formulas: number of moles based on mass over molar mass, and here number of moles, number of particles over Avogadro's number. And in this equation now, if I want to find the mass, what is the mass here? Just multiply both sides by molar mass. So that means mass here, it equals number of moles times molar mass. And here now, if you want to find number of particles, it equals number of moles times Avogadro's number. Okay, this is if you want to find this one. If you want to find the denominator here, just swap it with this one. So that means molar mass, if you want to find it, it equals mass over number of moles. Here, if you want to find Avogadro's number, you're going to divide number of particles over number of moles. I hope that is clear. And here we finished the first point of how to find mass, molar mass, and things related. Just we'll add one more note for this part. If I have now Fe2O3, this is now compound Fe2O3. Okay, this one now, as we know, it's compound and contains 2 atoms of iron and 3 atoms of what? Of oxygen. Good. If I ask you now, how many moles are in this compound? You're going to go always to see the number on the left. If it is 1, that means here now 1 mole of this compound. Good. If I have now 1 mole, how many moles of iron are there? If I have 1 mole of the whole compound, that means how many moles of iron I have there? That means if it was separated, this molecule, I'll get 2 moles of what? Of iron, Fe. Clear? And how many moles of oxygen? I'll have 3 moles of oxygen atoms. 3 moles of oxygen atoms in this case. Good. If I have now 3 moles, if I have 3 moles of Fe2O3, 3 moles, how many moles of iron are there? How many moles of iron are there in this compound? So 3 moles of this compound now, if they were separated here, you will get 6 moles of what? Of iron, which is 3 moles, and in each mole there are 2 moles of iron. So 3 moles, this is the whole box of the atom, and inside each box you have 2 moles of iron. So in this case you have 6 moles of iron inside this 3 moles of the compound. Good. Okay, we'll go now to the next point. We'll go now to the next point, which is law of constant proportions and law of multiple proportions. And this one is not related to what you studied previously, which is number of moles and what. Okay, we here now in the second point, just we're going to talk about number or law of what? Of constant proportions. And also we have law of multiple proportions. Okay, what is now law of constant proportions and law of multiple proportions? Look, if I have now NaCl, or if I have, for example, H2O. Now, if I have this compound, which is H2O, we know that the mass inside this compound, the mass of oxygen is 16. Good. And we know that molar mass of oxygen is 16. Good. And the mass of hydrogen is 1 times 2, which is what? 2. And the mass of all this one now is 18, that whole mass of the compound. Okay, if I ask you now, pay attention, what is the ratio? What is the ratio of hydrogen mass to oxygen mass? What is the ratio of hydrogen mass to oxygen mass? In this case, you're going to see the mass of hydrogen is 2 to the mass of oxygen, that is 16. If you simplify it, it's going to be 1 to 8. And as we know, ratios, they are fractions. Ratios, they represent what? Fractions. So 1 to 8, it can be written 1 to 8, as you see. So this ratio now, as you see, it represents whole numbers ratio. That means 1 is a whole number and 8 is a whole number. So this ratio now is the ratio of what? The ratio of what? It is the ratio of hydrogen mass to oxygen mass. In what? In H2O, which is in water molecule. Okay, now, this ratio now, will it be changed if you have a lot of molecules of water? Or if you have different molecules of water, will this ratio be changed? No, it will never be changed. So this is now what is called law of constant proportions. So it states that the ratio of the mass of an element to another element in its compound is constant, and it represents, as you see, whole number ratio all the time. So that means whenever you have H2O, whether in this country or another country, in this sea or in that sea, wherever you see water, the ratio of mass is constant. The ratio of mass of hydrogen to oxygen is 1 to 8. And this is the ratio is what? Constant, regardless of the number of molecules you have, and regardless where that number of molecules or where that molecule came from, regardless. So the ratio here is constant, and this is what is called like law of constant proportions. Okay, what is law of multiple proportions? Okay, here now, if I have now, we're gonna deal with oxygen and hydrogen as well. If I have hydrogen and oxygen, they can make H2O. This is a compound. And also they can make another compound. So that means they can, if they here these two elements, they can make this compound and they can make another compound. Like what? H2O2, which is dihydrogen dioxide. Good. This one now, as you see, the same two elements. Again here, the same two elements, which is hydrogen and oxygen. They produce, or they can produce, two different compounds. Good. What is multiple or law of multiple proportions? What does it state? Okay, it states that if we have an element that with another element or other elements can produce more than one compound. In this case, the ratio of this element mass in its two compounds will be a whole number ratio. How does that happen? We're going to explain it here. Here now, if we are talking about this compound now, what is different now is oxygen. Oxygen here is 1 and oxygen here is 2, but hydrogen is still the same, H2 and H2 here. So we deal with oxygen. Oxygen here, what is the mass of oxygen here? The mass of oxygen, as we know, molar mass of oxygen is 16. So this one here, 16 grams. Good. What about the mass here of oxygen? As you see, you have two oxygens, so the mass is what? 32. So if we divide now the mass of oxygen itself, if we divide them, if we compare them to each other, we're going to see that the ratio is 16 to 32. If you simplify it, it's going to be 1 to 2, and it represents 1 to 2. So the ratio now, as you hear, it represents whole numbers ratio. Whole numbers, because the 1 is a whole number and the 2 is a whole number. Good. So whether is it 1 to 2 or 2 to 1, it's the same. So that means this one now, it depends on the order of the compounds you write. So that means now the mass of oxygen in this molecule, in this compound, to this mass, or to the mass of oxygen in the second compound, is ratio is 1/2. So the mass here, we are talking about the mass in multiple proportions here. We are talking about one element only. We are dealing with the mass of one element only, which is the element of oxygen here. It was 16, becomes 32. This ratio now, it represents 1 to 2, and it represents the law of multiple proportions. And in general, it states that if an element can make more than one compound with other elements, like here oxygen can make more than one compound with hydrogen. It can mix like water or this another element. So that means a compound. So it can make two compounds with the same other element, which is hydrogen. In this case, the ratio of the masses of the same element, which is oxygen, will be whole number ratio. Will be what? Whole number ratio, like a whole number in numerator and in denominator. So that means 1/2 or 2/1. It depends on the order. And it's still what? Whole number. So that means we understand now what is law of multiple proportions, and we deal with it if we are talking about just one element that makes more than one compound with other element. And law of constant proportions, we deal with two elements when we compare them in a compound with two elements or three elements, their ratio will be constant in their compounds wherever these compounds come from. Okay, here now we finished the second point. We'll go to the third point. The third point is we're going to explain two things on it. We're going to explain what? Two things on it, which is molecular formula, and also empirical formula. Okay, now what is the difference now in molecular formula and empirical formula? Molecular formula, it represents the number of atoms in a compound as they are. How? For example, now if we have a compound that is called what? Ethane. And we know ethane, it contains 2 carbon, and hydrogen will be 2 times 2 plus 2, it represents what? 6 hydrogen. So that means ethane has 2 carbon and 6 hydrogen. So what does this one represent? It represents molecular formula. Why? Because it gives us exactly the number of carbon atoms and the number of hydrogen atoms as they are in the compound. So this one is called molecular formula. So molecular formula for any compound, it gives you the real number of atoms for each element in that compound. So we call it what? Molecular formula. Okay, what about empirical formula? Empirical formula, it is a simplification. It is here a simplification. It is what? Simplification of what? Of the molecular formula. So as you see here, C2H6 here. If you simplify it now, can you simplify it? Yes, I can simplify this formula by dividing the two here elements by 2. If I divide by 2, what will I get? I'll get C1H what? H3. So this one now, is it still called molecular formula? No, because now it doesn't give us the real number of carbon atoms or the real number of what? Of hydrogen atoms. But now, since it is the simplest form as whole numbers 1 to 3, so that means in this case we call it what? Empirical what? Formula. Empirical formula, we use it in calculations to make things easier when we calculate it. If we want to find the ratio of carbon atoms to hydrogen atoms, it is what? 1 to 3. So we deal with it like what? Empirical what? Formula. So you understand now the difference between molecular formula and empirical formula. Okay, we'll go now to the fourth point. In the fourth point, we're going to understand what is the mass ratio. What is the mass ratio? Okay, the mass ratio now of elements in their compounds. We take example if we take here water. So that means we are talking about what? Mass ratio. And we are talking about mass ratio. That means we are talking about mass ratio of elements in their compounds. Okay, if we have also, you're going to take H2O just to be easier for you to memorize. So H2O now, what is the mass of hydrogen? We know the mass of hydrogen is 2 times 1, and here it means what? As we know, it is 16 grams. Okay, here now, the ratio is 2 to 16, which we say what? It is 1 to 8. 1 to 8. This ratio now, if we are talking about now, what is the mass of hydrogen or as a percentage in the whole compound? Okay, this is now the ratio of mass, which is related also to constant law or law of constant proportions, 1 to 8. Okay, now, if I'm asking now, what is the ratio of the mass of hydrogen in the whole compound, which is H2O? What are you going to do here? You're going to divide 2, divided by the whole mass. What is the whole mass of the compound? The whole mass of the compound here is, here you have 2 and you have 16, so that means the whole mass is what? Is 18. Okay, so if you simplify it, it's going to be 1 over 8 1/9, and 1/9 you multiply it by 100 to make it as a percentage, which is called what? Mass ratio of hydrogen element in its water compound. In its water what? Compound. Or the same for what? For oxygen. So mass ratio, it can be the ratio of the mass of an element in its what? In its compound. So that means to get this mass ratio, you divide the mass of the element in that compound, which is here the mass of hydrogen is 2, divided by the molar mass of the whole compound. The molar mass of the whole compound, as you see it, is what? 18. So to get the mass ratio of an element in its compound, just we divide the mass of that element divided by the molar mass of the whole compound. Then you multiply it by 100 in order to write percent, in order to change it into what? Percentage. And that is what is called what? Mass ratio. Last point we are talking about now is hydrated salt. What is hydrated salts? Hydrated salts are salts that are attached to water molecules. That's it. So that means if I have a salt and we take here, for example, like CaSO4. This one we know it is what? Calcium sulfate. Calcium what? Sulfate. If this element now, or I mean if this compound now is attached to water molecules, is attached to what? To water molecules, and we write it by writing here like a dot or a point in order for this one now to be a whole molecule. A whole molecule of salt and also what? Water molecules attached to it. And this one is called what? Hydrated salt. Okay, this one now here, as you see, we are talking about usually about 1 mole of this salt. And not all the salts of 1 mole, they'll be attached to 1 mole of H2O or 1 molecule of H2O. So that means in general, H2O can be more or double in number of moles or number of molecules. So that means if here is written 2, so that means now 1 molecule of calcium sulfate is attached to 2 molecules of water. Okay, how we read this one now? We read it what? Calcium sulfate, and we read here what? This is water, but we read it here as what? Hydrate. We deal with it what? Hydrate. And just we need to mention what this number represents. Like if it is 2, we write di. We write what here? Di. If it is 3, we write tri. If it is 4, we write tetra. If it is 5, we write penta. And it is 6, we write hexa. Then penta. Then like this. Then hepta, which is 7. Then octa if it is 8. Nona if it is 9. And Adika if it is 10. Good. Here now, how we write this one now? We said we write it as calcium sulfate. Gets calcium sulfate, we wrote this one here now. Now this one now it is 2, so we write it what? Di. We write it what? Di. Then instead of water, we write it what? Hydrate. We write it what? Hydrate. So this is now how we read hydrated salts. And what are hydrated salts again? They are salts that are combined with molecules of water. And just we read them now as calcium sulfate, or the salt, whatever is it called, we write it or we read it as it is, and we mention the water as hydrate, and we write here the number of molecules of water as a prefix that indicates this number. If it is tri, we write it tri. Okay, and we take here another example as well. If I have magnesium also, magnesium as O4, which is magnesium sulfate as well. If it is here attached by 7 H2O, how do we read this one? We read it magnesium sulfate. Then this 7, we write it what? We write it hepta. Then what here? Hydrate. Good. Now, the idea here now, we understand what does it mean hydrated salts. We understand now what does it mean what? Hydrated salts. Good. We understand what is hydrated salts. We said it is salts that are attached into what? Or attached with, or that has attachment of water molecules to them. And we understand how to read them and how to write them. Good. But what do we need to understand more about hydrated salts? We need to understand that these hydrated salts, we can heat them to get rid of these attached water molecules. So that means this one now, you see it? If we heat it, what will happen? Water will get evaporated. Part will get what? Evaporated. And what will be left then? Also only what? Magnesium sulfate. And it's the same for calcium sulfate. Good. So that means, good. If the questions comes to you, they're going to tell you that hydrated salts, its mass, for example, is 10 grams. 10 what? Grams. After we heat it, its mass will become 8 grams, for example, 8 grams. Then they ask you what was the mass of water molecules attached to it. So in this case now, you're going to subtract the hydrated salt, which is the salt with water, minus the anhydrous salt, which means minus the salt when it is without water. When it is without water, in this case, you get the mass of water. I hope you understand now these points and you can answer the questions that are related perfectly. Thank you. See you in other videos.